NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. Now that we have a basic Hello, welcome to LabRad's Engineering GeeekPi Tech Talk 101 and an introduction to Git and GitHub. This video will introduce two great tools for software developers, Git and GitHub. Git is a free open source version control system designed to track changes in source code during software development. It allows multiple developers to work on the same project simultaneously without overriding each other's changes. Why developers use Git? It has historical tracking. You can revert files to or entire projects back to any previous state. It allows for collaboration. Teams can work on different features of the same project at the same time and merge them later. It has security. Every change is cryptographically checked, summed, making data corruption or loss nearly impossible. Offline capabilities, as most operations happen locally on your machine, requiring no internet connection. Here is a block diagram of Git and how we'll be going over how it works. Git tracks changes locally on your computer through three main states: the working directory, the staging area, and the local repo. The working directory, the actual files you see and edit on your computer. The staging area is a preview zone where you prepare and draft changes before saving them. The local repo is the permanent database where your Git permanently saves your committed snapshots on your machine. And then the remote repo is the permanent database where Git or GitHub permanently saves your committed snapshots on the cloud. The core concepts are repositories, these two repositories. The repository is a database containing all your project files and their complete revision history. You have the ability to do a branch off the main line, an independent line of development used to work on new features without affecting the main code, allowing collaboration, and then you merge, the ability to merge. The process of combining history and changes from one branch into another. The core commands are add, the git add. You add your current file changes to the staging area. Git commit, a snapshot of your file at a specific point in time, acting as a save point to the local repository. Right there. The git push, to update the remote repository with your snapshot, allowing everybody to see what you have altered or changes you've made. Merge integrates history of a specific branch or specified branch into your current branch. It's right there. Git fetch downloads the latest history from the remote repo without altering local code. That's right here. A git pull fetches remote changes and immediately merges them into your active branch. Git checkout switches your current working directory to a different target branch, right there. And then Git clone copies an existing remote repo from a server to your machine. GitHub, which is Git and GitHub, are owned by Microsoft and they are supported by Microsoft. GitHub allows us to work on Windows and to use the functionality of Git without doing command line terminal. We'll go more into that in the next video. Here is a video. You must watch this. It's a tutorial on how to use Git from a terminal line, but you'll do the same processes or same techniques through GitHub, and we'll learn how to do that. Please watch this. It's very good. It's written by Nick White, who did a fantastic job.
That's how I think. So I'm going to break down Git. Instead of you going and watching the 6-part tutorial or paying or whatever, it's really very simple. If I teach you it I'm going to teach you like you are a child, and you are my children. And if you're my new child, meaning you're just born, then hit subscribe and like the video. Alright, so this is unscripted, but first thing I'm going to say, get this out there. Git and GitHub are two different things. I'm going to talk about both of them in this video, but I'm going to start with Git. So let's begin. What is Git? Well, Git is a software that comes with your computer and installed on your computer if you have Mac or Linux. So if you have a MacBook or an Apple computer, you have Git already. Or Linux computer, you already have Git. If you have Windows, you have to download it. So you're going to have to download something called Git Bash. You go to the website, you download it, and then it's like a little terminal window. Use that. Is Git something you need to know? Yes, Git is something you need to know. You are not going to be successful at programming without knowing Git. Everyone needs to know it. It's like one of the most basic things. It's like terminal. You need to know you need to know a command line, you need to know Git, and then you need to know how to code. Okay, so what does Git do? Why do I need to know it? Here we go. This is as simple as it gets. Simple as it gets. Git is a memory card for code. If you have a project with a bunch of files, HTML, CSS, JavaScript, whatever programming language you want, just like how you have a video game, you want to save your progress as you go. That way, if you die, you don't lose all of your progress. So with Git, every so often, you're going to enter a command to save your progress. Now, this is locally on your computer. Nobody else can access this. You have this on your computer. So I'm going to go through an example now. I'm going to create a folder, Git video. I'm going to go into my Git video, and then I'm going to make an index.html file and an app.css file. So I made a folder, and I made an HTML file and a CSS file. Now, if one of these files gets deleted, I didn't save my progress. It's gone forever. I don't know what was in the file. If I wrote a bunch of HTML or CSS, one of the files gets deleted, poof, oh well, I can't do anything about that. It's gone forever. But if I use Git and I save that I made these files, I could save them with the contents of the files. And when one gets deleted, I can go back to my saved progress. Now, to use Git, you have to know a few commands. There's only a few, and it's not that hard to understand. The first one is initializing your folder or project with Git. To do that, you have to have Git downloaded, and then you type git init, initialized empty Git repository. Great. So that's the same thing as you're putting a memory card into your game system, because you obviously can't save the game without memory. So here we go. Now we can use Git. We want to save our progress. How do we do that? Well, Git Add is what you want to save. We can save all of our progress, meaning all of our changes since the last time we saved, or we could just save a very specific thing. So after Git Add, you want to put either maybe a file that you want to save. So I could just save index.html, but if app.css gets deleted, it's gone forever. But I could just save any changes I've made to index.html, or I can save everything. So git add space period would save everything that I've done since the last time I saved. I almost never commit a specific file. I usually push changes onto everything. So in 95% cases, you are going to use git add period and commit all of the changes that you've made. Okay, so now I've said what changes I'm saving, which I chose to save everything. Now, if we were to get technical, I have added all files to the staging area, but that might just confuse you, so don't even think about that. I've added the files I want to commit. I've added everything. I am going to save everything. Now, git commit actually commits those changes to memory. So you type git commit, and then you need to do -m for a message, -m, and describe the changes, describe the save. This way, when we look back, if we want to go back to this save progress, we know what we're going back to. So you make the message about what you're saving. Make sense? So I'm going to say add HTML and CSS file. 2 files changed. You see that I created 2 files. It got saved. That progress got saved. Now, if I delete my HTML file and I add a JavaScript file, well, now I've made some more changes and I could save my game again. So now we only have app.js and app.css. So let's do it again. Save all my changes, git commit -m, delete HTML, and add JS. So I've saved my progress twice now. What we've gone over so far is how to add the files you want to save and then commit with the message to, save the progress of the message. And git init to, start it up. Now, if we type git log, we can look at our saved, the times we saved. Look at this. So this is the first time we saved. It's a log, git log. It's a log of all of your saved changes. Add HTML and CSS. Just gives you the time, gives you the date. Fantastic. And then it gives you this little hash code used to go back to it. And then look at this. There's our second one, time and date with the hash code. Now, if I want to go back to my previous progress with the HTML and the CSS where we saved, I can copy this like hash code thingy, majig, and then look at this. Git checkout to check out that commit. Let's see where we're at. Oh, we're back to our first saved progress. Now, here's the tricky part, is that when we go back in time, we're in a different branch. So now timelines are getting messed up and we're in a time machine. Oh God, dude, maybe I shouldn't go with the time machine analogy. I want to keep this organized and I don't want to give too much to you to confuse you. Now, what is GitHub? Well, GitHub is a website. And it's the same thing as Bitbucket, and it's the same thing as GitLab. They are websites where I just put the stuff that's on my computer, all my saved progress is on my computer, and I put it all on the internet so that other people can download my code and then go through all my saved progress. They could go back and forth. They could jump through time loops and go back to my saved progress and look through all my code and do whatever the hell they want to do. So how do you get your code onto GitHub? Well, you make a GitHub profile, and then you make a repository. Repository means folder. Folder means repository. Same thing. So you're on your thing. You go to repositories on your profile. You hit new. You hit new repository. You type the name of it. Mine was Git Video. Description. You could have a public or private. Whatever. So now, once you do that, it gives you instructions to hook this up to your folder on your computer. My folder's on my computer. I want it on the website. It tells me how to do that. It gives you specific instructions. It says git remote add origin. This is a command to just hook it up to the website. So let's just do that. All right, ready? Boom. Okay, I added the origin. And now this is called a push. So you have your saved commits, your saved progress, and then you push it. You push to the website. Okay. And now we go to the website. And there is our code, people. Ladies and gentlemen, there is our code. The CSS, the JS, and then the two commits that we can look through. Here's the first one with the HTML CSS. Here's the second one. Now someone else can go to my profile and see this, and they can download it onto theirs. And that's why GitHub is something you have to know, so you can work with others on projects from different areas in the world. Because whenever I save my progress, I push it up to GitHub, and whenever they want to see what I'm doing, they go to my GitHub, and they can just pull my code down, or they can just look at it on my profile. Now, do I want to go into branches right now? No, I don't. This video's already been long enough, but I will. Now, there's these things called branches. So by default, all the code is on a master branch. Don't overthink this. I know you're overthinking that. That just means that's regular. That's just regular. That's just you coding. You're saving your changes. They get saved to the master memory. But someone can go off, like in a video game. They could trail off of your game. And then, you know when you play a video game and then you do something and it's on your friend's account, but you don't want to save onto their account because they still might want to play what you just did? So you save it into a new file. So that's a different branch. Someone could download my code, make changes, and they do it on a different branch. So if we go back to our folder and I type git checkout -b, that's going to make a new branch. And I'm going to call it new branch. You put the name of the branch you want to make. So now I have a new branch open, and there's a master one still, but now I have new branch, and I can make changes, and it won't affect the main game saving, the main code getting saved. It'll just be my own branch trailing off of that code. So I'm going to add a Python file, app.py, and I'm going to commit. I'm going to do git add everything, add all my changes, git commit, add Python file. And now if I do a git log, you can see I got my 3 commits, but this is for my new branch. I'm on new branch here, but this stuff is from master. Now the cool part about branches is that I can merge my changes on new branch into master if I want to, or I cannot do that if I don't want to. So if I want to merge if I change like 50 things on my new branch, I can push them all into the main one if I feel like it. And if I don't want to, then fine, I don't. I can delete the branch. I can do whatever I want. It's irrelevant until it goes into master. So the point of branches is so that other people can download your project. They can go and make changes on a separate branch. And then they can come to you and be like, dude, I made all these changes. I didn't want to mess up what you were doing. But hey, look at these. If you like them, merge them into what you were doing. And then I can. So what they would do on GitHub is they would say, hey, let's push origin new branch. You could push the new branch up to GitHub. Oh, look at that. There's 2 branches on GitHub now. One of them is new branch, one of them is master. So if someone wanted to say, hey, dude, check out my progress, they could do what's called a pull request. And whoever owns the repository is going to get that and look it over and say, hey, these are good or not. So you can say, hey, dude, I changed some stuff. Check it out. And then you create it. And then whoever owns the project might be like, oh, this guy went and changed some stuff. Let's see what he changed. Oh, they looked. He added a Python file. Maybe I want that. So that looks pretty good. Good job, dude. You made some good changes. And then you merge it into the master. And then you confirm the merge. And look at that, dude. Now it's merged into the master. And, you know, dude, it's got the commits from the new branch. They got pulled into the freaking master branch. So now everything is in the main area because the guy liked the new branch. Now, one thing that's important is you always want your local computer synced up to GitHub. You want these connected because it can get out of whack. You need these to be at the same spot. So when there's changes on GitHub that you don't have on your computer, you want to pull those changes down to your computer. You push, when you have changes that GitHub doesn't have, you push them up to GitHub. When GitHub has changes that you don't have, you pull them down from GitHub. So I will do git pull origin master. And now I pulled down those changes, that Python merging that went on up there. I got them now on my computer, and we could check that out. We got the merge, we got the Python file, and everything is now on our local computer. Now, for rebasing, I do need to get a little more technical with this, and I think I might make a future video specifically about Git rebase. But these are the basics, and you can probably get by on just these and maybe pick up rebasing on your own. I don't want to overcomplicate or make you overthink. These are the basics. This is all you need to get started using Git and GitHub. You don't even need to get into branches really, because you might not even be working with those right now. Just pushing your code up, pulling your code down, making the changes, the save changes. When there's stuff on the GitHub that you don't have, pull it. When there's stuff on your computer GitHub doesn't have, push it. You do not need GitHub to use Git, and you probably do need Git to use GitHub, but you don't need a GitHub if you just want to save your changes. But you need a GitHub probably when you want to collaborate with other people in different places, and you'll probably need it for like every project ever. Now, some parting words about GitHub that you might be interested in. People will judge me because I don't have all these green squares. So, if you want to set up some kind of auto commit thing, you get a green square if you push code to GitHub every day. So people like to code every day and have all these squares look green, and sometimes they don't push anything useful. They might specifically change or add a comment just so that they have a green square on GitHub. These are people called clout chasers, specifically GitHub clout chasers. And they don't make impactful contributions to projects, and they specifically want green squares to flex on other developers. You can be one of them, or you can let it go and just move through and actually, do real things with your life. So that is it for this video. I hope I made this very easy for you to understand, and I'm going to put a black screen at the end with all the commands we went over, and there's only a few, and it's pretty straightforward. So that is why this video is the best Git tutorial out there. Please like and subscribe to show me support. Thanks for watching, and I'll see you in the next video. Bye.
Now that we have a basic understanding of Git, let's install it on our computer. Click the link showing in the monitor to see the Git download. Click on that. That brings us to this page. We want to select Install for Windows. I want a 64-bit setup. I click that. And of course it won't do it now. There it goes. That's just my luck. Okay, it downloads it. We can see it downloading it. Here it is right here. And that's in my downloading directory. Right there it is. Fantastic. So I'll double click on it. You can just start it from right here. Here is the beginning window. I want to say yes, install on my machine. We get the GNU General Public License. Read through that if you want, if you have nothing else to do. And I'm going to click Next. I'm going to store it on my C drive under Program Files. Put it anywhere you want. I want additional icons. I want it on my desktop. I want to check for daily Git updates. And I want to add a Git bash profile to my Windows terminal. I select keep everything else the same. I select Next. I'm going to name the directory Git. And I don't want to use the VMI editor. I want to use Notepad++. I select that. You got Visual Studio. We do several. And I might change it. Like Git decide, default branch, currently master. I'm going to let Git decide that. I'm going to use Git from a command line and also from a third party with GitHub. I'm going to bundle my source, secure source. Use Windows secure channel library. Keeping everything the same. I'm just going to go through here and say install. Here we go. All right, hit completed. We're going to launch the Git bash. Select finish. There we go. Here is our terminal command line Git terminal. But we're going to be using GitHub, which was be taught in the next tutorial. Go ahead and close that. Close the release notes. Iconize this and this. But here I'm going to go show you what it put in the C drive and the Git directory under Program Files. The Git. And this is what we have here. Okay, that's it. Lab Rats Engineering, I wish to give Nick White a like and subscribe. Here's his webpage, a YouTube channel. Go to that and select like and subscribe to his many tutorials. Highly recommend them. That's it. The next video will be covering GitHub, and then we'll go into the IDE and we'll begin our first project right after that. Thank you. Here at Lab Rats Engineering, NextPCB is our one-stop solution for PCB manufacturing, PCB assembly, and DFM analysis. They offer a wide range of high-quality PCB services, including multi-layer HDI, flex, rigid flex, and metal core PCBs. NextPCB also provides complete turnkey PCBA services from component sourcing to assembly and functional testing, ensuring precision, reliability, and fast turnaround. with express options available in as little as 24 hours. What I really like is their professional support, fast shipping, and consistent build quality. Their one-on-one engineering service also helps ensure your design is optimized for manufacturing. If you're getting started, NextPCB offers a $20 discount on your first PCB order, which is essentially enough to get your first PCB made for free. Use NextPCB as your comprehensive solution.